Brewing. In this video, we will go through the beer brewing process from milling the malts to packaging the beer. First, water for mashing is added to the equipment to be heated. Grinding of malts. The malts are weighted according to the recipe. The malted barley is grinded to enhance enzymatic reactions and extractions, speeding up the process. Finer grinding improves extract yield. If malt is grinded too finely, separating the mass from the wort becomes challenging. Mashing. Once the desired mashing temperature is reached, a seal is placed on the malt pipe, and steel filters are added to the bottom of it. The malt pipe is placed in the equipment. Crushed malts are added to the malt pipe, ensuring thorough mixing to avoid clumps. The mass needs periodic stirring. In this video, the equipment pump handles the mixing. After adding malts, upper steel filters are placed in the equipment. Enzymes in the mass breaks down starch into sugars. Yeast uses these short sugar chains as nutrition, producing carbon dioxide and alcohol. Long sugar chains contribute sweetness and texture to the beer. Color and aroma from the malt dissolves into the mashing water. Usually, mashing process lasts an hour. Mashing ends with the mash out phase. Temperature is raised to around 77 degrees Celsius and maintained there for 5 to 15 minutes. Mash out stops enzyme activity, facilitating easier separation of the mass. Straining and rinsing. The liquid containing dissolved malts is called wort. Filtration aims to separate solid mass particles from the wort. Rinsing starts by slowly recirculating wort through the malt bed. This clarifies the wort. Rinsing continues with the recipe-specific amount of heated water. Care is needed to be taken to avoid quickly added water compacting the malt bed, blocking wort exit path. After rinsing, the malt pipe is lifted and the equipment temperature is raised to the boiling point. Boiling and adding hops. Wort can be hopped in various ways. In this beer recipe, hops are added at the beginning of boil to achieve desired bitterness. Hops significantly impact beer flavor and aroma. Wort is boiled for 1 to 2 hours. It serves various purposes: denaturation of enzymes, precipitation of proteins, evaporation of water and undesirable compounds, dissolving the hops, and wort sterilization. After the boiling, hygiene is crucial. Measuring specific gravity. A sample of wort is taken to measure specific gravity, indicating sugar concentration in wort. Knowing specific gravity of post-boiling and fermentation, the recipe parameters about mass efficiency, fermentation degree, and alcohol content can be followed. Wort clarification. Clarification using a whirlpool involves creating a strong vortex, separating hop solids and precipitated proteins from the wort. The remaining mass is called drup. In this video, the equipment produced clear wort, eliminating the need for clarification. Cooling. Plate heat exchanger is used to cool the wort. Cooling the wort to yeast pitching temperature should be done rapidly, as cooling wort is sensitive to bacteria. After boiling, special attention to hygiene in vessels and tools is required to prevent contamination. To enhance cooling, liquid cooling device can be attached to the fermentation vessel's cooling jacket. Yeasting. Dry yeast can be added directly to the wort or rehydrated and then added. Yeast requires oxygen to grow, which can be added to the fermentation tank. Small beer batches can be agitated in the fermentation vessel. Yeast influences beer aromas and overall taste. An airlock is installed on the fermentation vessel. Fermentation. Alcoholic fermentation is an aerobic process. Oxygen was added in the aeration phase to aid yeast growth. Once oxygen is consumed by yeast, actual alcohol fermentation begins. Yeast converts sugars to alcohol and carbon dioxide. The temperature and duration of primary fermentation depends on the beer type and yeast used. Diacetyl, a butter-like flavor, may occur, prompting a diacetyl rest where temperature is raised, allowing yeast to consume diacetyl, eliminating the off flavor. Post-fermentation. Beer is transferred for secondary fermentation in kegs or bottles. Specific gravity is measured after fermentation to determine if fermentation is complete and to calculate alcohol content. Beer carbonation can be achieved with the fermentation. In this video, liquid sugar is directly added to the bottle, where fermentation produces carbon dioxide. Carbonation with the sugar fermentation is slower but simpler compared to the other methods. If beer can be transferred to a keg, it can be carbonated with carbon dioxide. Carbon dioxide dissolves in beer, forming carbonation. Secondary fermentation is crucial for beer flavor, clarity, and saturation with carbon dioxide. Packaging. Carbonated beer can be transferred from the keg to bottles. Bottled beer should be stored cool and protected from light to avoid off flavors. It's recommended to enjoy beer fresh after secondary fermentation.